Okay, well, let's get really Buck Rogers now. Nanotubes. Nanotubes are cylinders where the walls of the cylinder is 1 atom thick of carbon. This is a nanotube forest at an incredibly tiny level. And some people realize, okay, wait a minute. Yeah, we got these cylinders. They're 1 atom thick, so they're really tiny, so you can pack a whole bunch of them. What if instead of a crystal, we put the hydrogen in these in this nanotube forest, and then we push it in, then suck it out again when we need it. Once again, if mankind, well, what you would trigger the reaction with is an electric charge. You would apply a certain charge to make the nanotubes absorb hydrogen. And then when you need it, you would fiddle with the state of the system so that it then releases the hydrogen. Unfortunately, once again, if we ever reach that point where we can control nanotubes this well and build them cheaply, that will produce ultracapacitors. Ultracapacitors are like hyperactive batteries. An ultracapacitor can't store charge for a long time, but it can hold a lot of it. It can hold a lot of it fairly cheaply, and it can give and take, charge and discharge, just like that. Zoom. So once again, it's not a hydrogen advantage, it's a hydrogen disadvantage. Mankind working on these micro gas cylinders. Okay. What if we don't actually sell people hydrogen? There are hydrogen carriers like methane or methanol, natural gas, or even petroleum. Petroleums are hydrocarbons. What if we take these hydrocarbons or alcohols and strip the hydrogen off the carbon? Hey! Well, the way you do that is you heat up your molecule a bit so it will let go of its hydrogens. This takes a reasonable temperature, a couple hundred degrees, reasonable fire. It's not like the surface of the sun or anything, or a rocket engine. But so you've solved the tank problem because now your tank holds something like, I don't know, Bic lighter fluid or ethyl alcohol or something. That liquid at room temperature, very handy. But now you have to add an extra step in the system, this reformer that will strip off the hydrogens. If you have a reformer, well, yeah, aside from the extra cost of the reformer, if you have a reformer that is operating at a couple hundred degrees, then all of a sudden you get these other fuel cells. Now, when you hear people talk about hydrogen cars, they're really talking about polymer exchange fuel cells. And the reason that is because ADC, that's very reasonable. Aside from, the squeamish people who are like, ooh, hundreds and hundreds of degrees right in front of my feet. There's the issue of practicality in that if a car engine is cold, well, yeah, it'll run, you're doing some damage to it, you're accelerating wear, and you're shortening the life of your engine. But if a fuel cell is not at its operating temperature, you get nothing. You can't you drive slowly for a minute or two. You can't, just like putter through residential streets before you hit the highway. No. Fuel cell, you get nothing. And I certainly would, but would you accept a car? Would you buy? No one's going to give you one. Would you buy a car that you have to sit there and wait for it to spool up to a couple of hundreds of degrees? That's minutes. And
just for comparison, what is a gasoline engine operating?
Yeah, gasoline. I'm thinking low thousands. Not much of a petroleum guy myself, but low thousands. But like I said, you can just drive slow for a minute or two because the gasoline engine is heating itself. And yeah, if you're willing to accept a little wear, oil's not there yet, a little shortened lifetime. Yeah, you just putter for the few minutes. Now, why people are talking about hydrogen is because this low temperature fuel cell, well, both polymer exchange and alkali, they need ultra pure hydrogen. Your high temperature fuel cells, if they have contamination in them, they'll burn it right off because they're hundreds of degrees. So like any other engine, you're taking in air, and air is reacting with your hydrogen. But if you have anything like organic contamination, dead skin cells flake off, pollution in the air. Some fuel cells are so sensitive that just running them in a polluted region puts other things besides carbon into the fuel cell. And that causes fuel cell poisoning because the hydrogen and oxygen come together on a surface, which is like a polymer exchange membrane. In this fuel cell, the surface is a membrane. Hydrogen goes through the membrane, contaminants don't. So if you let that go too long, these contaminants will slowly coat your fuel cell, and then it stops running. And some of them stop running, some of them are destroyed. And so for these low temperatures, not just 99% hydrogen, you need like 99.999% hydrogen, or you might destroy them. The high temperatures, yeah, are high temperatures. If there's a little gunk on the fuel cell, burns right off. The air just it lights in air. Realizing that people aren't going to accept a car that they have to sit there for a while. Like, when was the last time you bought milk? Would you say to yourself, "Oh, you know what? I gotta eat, I don't know, oatmeal because I didn't warm up the car for 10 minutes. I can't go get milk." Not going to happen. So if you had an onboard reformer at a couple hundred degrees, you would simply use a high temperature fuel cell and you wouldn't need the reformer because a high temperature fuel cell, you just feed it methane directly, or methanol, or ethyl alcohol, or butane, or any of hundreds of other hydrogen containing substances. So yeah, this problem is a dog chasing its own tail. No one is seriously pursuing onboard reformation. Yeah, because the problem solves itself then. So all in all, National Academy of Engineering, pretty respected body, says, no. How are we going to store it? We can't store hydrogen. I believe the quote is, we would need to discover a new mineral for hydrogen storage to become practical. Okay, well, maybe we can work on that, Maybe we'll figure it out. Okay, so how do you get around? Okay, the hydrogen comes from someplace, and it's not your garage, so, there's going to be some trafficking, there's going to be some market. Pipelines. Like I said, since hydrogen can actually fit through the spaces between other atoms, this causes hydrogen embrittlement. That something like a pipeline or a metal fuel tank, it will eventually gain hydrogen atoms into its structure until it cracks and fails. And the kicker, here's a real kicker, the stronger your material is, generally, the more susceptible it is to hydrogen embrittlement. So, well, what are we going to do here? Yeah? Okay. Maybe not pipelines, What if we build tanker trucks? We can make them out of, a special, a custom tanks, things that can withstand hydrogen embrittlement, and then they'll shuttle around the hydrogen from the plant to the gas station. Unfortunately, like I said, because hydrogen is so light, you would need, what's the figure? I think 7 times as many tankers on the road for a hydrogen world than we do now for a petroleum world. And once again, wow, this dog is kind of chasing its own tail, because 7 times as many tankers means you gotta find 7 times as much energy for the company to be running these tankers. What's going on here?